In today's video lesson, we are going to look at the formation of ionic bonds. So we'll start with a few quick definitions to help us understand what's going on best. So an ionic bond is formed between two ions, a positive ion and a negative ion, and it's the attraction between those opposite forces that holds the ionic bond together. So an ion is a charged atom due to the gain or loss of electrons. So remember, all atoms, neutral atoms, are trying to reach that stable outer layer of the full octet. So they all want to look like the noble gases. So they do that by gaining or losing electrons to have a full valence shell. When they do this, they become an ion. There's two types of ions, cations and anions. So a cation is a positively charged ion. Okay, think of the T as being like a plus sign to remember that it's positive, or you can use the memory trick that a cat ion is positive. Okay, because it's a cat, positive. An anion is a negatively charged. Negatively charged ion. A way you can kind of remember that one is, if you can remember cation, then this is the other, it must be the negative one, but it has an extra N in it, so the N can be for negative. So we're going to start by drawing the Bohr-Rutherford diagram of magnesium. The nucleus contains the protons and the neutrons. There are 12 protons and 12 neutrons in the nucleus of a magnesium atom. And we're going to draw 12 electrons around the nucleus, because we're just starting with a neutral atom of magnesium. So I know that magnesium will need 3 energy levels because it's in the third row on the periodic table. The first energy level can hold 2 electrons, so there's 1, 2. The next level can hold 8. 1, 2, 3, 4, 5, 6, 7, 8. And then I have 2 more to make 12, is 2 in the third ring. So currently, my neutral atom of magnesium has 12 positive charges, so 12 protons, and 12 electrons, so 12 negative charges. So it overall has no charge. It's neutral as an atom. The Lewis dot diagram for magnesium is simplified to, we draw the magnesium element symbol rather than putting in the protons and the neutrons in the nucleus. And we only show the valence electrons. So the valence electrons for magnesium are just the outside ring. So there's just 2. Will the atom gain or lose electrons to achieve a full valence shell? In this case, it's easier for it to lose 2 electrons than it is to gain 6 more. So here we're going to lose electrons. How many? We're going to lose 2. So when we remove those 2 electrons, the Lewis dot diagram for the ion is going to be magnesium with square brackets around it and a charge of 2 plus. Now the reason, the way I know that this is 2 plus, is in magnesium, I still have 12 protons, but the electrons, I had 12, but I got rid of 2, so minus 2 is 10 negative charges total. So that gives me 2 positive charges as a net. Okay, and that's how we know what charge goes there. Now, is this ion a cation or an anion? It's a positive charge, positive like the T in cation, so it's a cation. Moving on, let's try another one. So here we've got oxygen. We're going to draw the Bohr-Rutherford diagram for oxygen. In the nucleus of oxygen, we know that there are 8 protons and 8 neutrons. So we'll draw those in first. And we're going to have 8 electrons, so 2 in the first energy level, and then 6 in the second energy level. So 2 at the top around the clock, 3, 4, 5, 6. In this unit, it's going to be really important that you're putting your electrons around your nucleus in your Bohr-Rutherford diagram or around your element symbol in a Lewis dot diagram, because it's going to help you figure out where the bonds are actually going to happen when we get to molecular compounds. So make sure you know how to draw them and distribute the electrons correctly. In this case, okay, we've got our Bohr-Rutherford diagram of oxygen. It has 8 protons and 8 electrons, so overall there's no charge. It's a neutral atom. Next, we're going to draw the Lewis dot diagram for oxygen. So we replace the nucleus with just the symbol O. We put only the valence electrons around it, 2 at the top around the clock, 3, 4, 5, and 6. So it looks like that. Will oxygen gain or lose electrons to fill the valence shell? In this case, for oxygen, it's easier to gain 2 than it would be to get rid of 6. So it's going to gain electrons. How many? 2. So draw the Lewis dot diagram for the ion of oxygen. Because oxygen has gained electrons, we're going to actually draw all the little dots in on this one. Remember when we did magnesium a moment ago, we didn't draw any dots around the ion. That's because we were looking at that shell level that we removed electrons from. And in this one, we're gaining, so we're going to draw all of them. Okay, for our charge, we have 8 protons still in the nucleus. Remember, the proton number is the identity of the atom, so that never changes. And the number of electrons, we had 8, and then we added 2 to give us a total of 10 negatively charged electrons, which gives us an overall charge of 2 minus, which we put in the top right-hand corner of our diagram. What type of ion is formed? Cation or anion? This is a negative, so it forms an anion. So now you may have even noticed that we have a positively charged ion and a negatively charged ion. And so we're going to look at what is the ionic bond that would form between magnesium and oxygen. So there are 3 steps to showing how this happens. Okay, step number 1, actually I'm going to write this in another color to make it a little bit differentiated. Okay, step number 1 is you're going to draw the Lewis dot diagrams for the neutral atoms, and we're going to show the electron transfer. So we're starting with the neutral atoms. So magnesium had 2 valence electrons with the neutral atom. Oxygen had 6 valence electrons in its neutral atom. So it looked like that. When we draw the transfer of electrons, we're going to use an arrow. The arrow shows that it's a complete transfer from one atom to another. We're going to do a different type of notation when the electrons are being shared. Okay, but when it's a full giveaway situation, we are going to draw an arrow, and you need to show exactly where those electrons are going. So you see how I've drawn it, and I've put it exactly where I would draw it in the next step. You can't just put sort of a vague arrow. You need to show exactly where things are going. Step number 2 is to draw the Lewis diagram of the ions. Okay, this is your ionic bond that we're actually drawing in this step. So now we've got magnesium, which we know has a charge of 2+ because it lost 2 electrons. And we're going to put it beside oxygen that has a full valence shell and a charge of 2-. And this is actually the ionic bond, the positive and the negative beside each other. So this is the ionic bond notation, okay, in step number 2. In step number 3, we're just going to give the formula and the name for the ion, or the ionic compound. So give the formula and name for the ionic compound. So in this case, we would have MgO, which we would call magnesium oxide. Now you've probably seen these 3 steps before, okay, in grade 10. So this is a little bit of review, but we want to make sure we know how to properly show everything. Because communication matters a lot in these things, and if you write something in a slightly different location, it can mean something different, and you might not realize it. Like if you put this number at the bottom, it no longer represents charge, it represents the number of atoms. So make sure you know kind of where exactly everything is supposed to go. We're going to do one more example together, one that's a little bit harder with slightly less scaffolding set up with it. And then you can do some practice. So here's our next example. We're still following the same 3 steps. So step number 1, we're drawing out the Lewis dot diagram for the neutral atoms involved. In this case, we're going to be looking at a compound formed between barium and bromine. So I'm going to start by just drawing one of each. Barium is in the second column, so it's in group number 2, the alkaline earth metals. So it has 2 valence electrons, just like magnesium. Bromine, okay, Br, is a halogen. It has 7 valence electrons. Okay, so we draw them out like that. And we're going to show the transfer of electrons. So I'm going to take one of these electrons, and I'm going to put it in that empty spot on that bromine. But now this bromine has a full octet. It has 8 electrons around it. It doesn't want another one. But barium has one more to give. So what we do is we add another bromine atom with 7 valence electrons. And we're going to transfer the second electron in that barium over to the second bromine atom. In step number 2, we're showing the ionic bond notation. So we have barium with a charge of 2+ because it lost 2 electrons. And then we have bromine with now 8 valence electrons. It gained 1. So it has a charge of 1-. But there's 2 of them. So you can either draw each one out like this, where you're kind of doing the long hand version, which can be safer if you're worried about getting things mixed up. So you can draw it out like that. So 1 of those, 2 of those. Or you can write it as a shorthand, and you can have your barium 2 plus, and your bromine 1 minus, but you would give it a subscript of 2 down here to indicate that there's 2 of them. They still only have each a charge of 1 minus, but there are 2 of them. So a mistake that often people make is they'll put 2 minus here because they think, oh, the bromine has gained 2 electrons. But this particular spot is to show the charge on one single atom of that type or ion of that type. So the 2 down here tells me I have 2 of them. The negative symbol here tells me each one has a charge of 1 minus. So be careful with that. Step number 3 is to give our formula and our name. So BaBr2 is our formula. So we're just taking out the ion notation and indicating how many of each atom type we've got, or ion type we've got. And then our full name is barium bromide. And because it's an ionic compound, we don't need any prefixes or anything to say how many of anything there is. We can figure that out just by the crisscross of the charges, the way that we normally do. So you've got some practice to work on, and then we'll check it later.